This week, we're going to be talking about probability and probability distributions. I wanted to start this first video with a quick introduction to what probability is, how we calculate it, and how we interpret it. So probability is a measure of how likely something is to occur. You see it all of the time. We know when we talk about weather in the news, we talk about how likely it is to rain, how likely it is you are to win the lottery. Probability is something we're familiar with in day-to-day life. In statistics, we can calculate it using what we know about how the system behaves. We call that theoretical probability. If you play card games, go to casinos, they talk about card counting, which you should not do. All of that's based on theoretical probability. We know what a deck of cards looks like, so we understand the likelihood that I'm going to draw an ace. We can also calculate probability using actual data collected from the system, and this is called empirical probability. For theoretical probability, if I want to calculate the probability of event A happening, I take the number of ways that I can get A, and I divide it by the total number of outcomes. That is not how you spell possible, Mr. J. So for example, I talked about drawing an ace. If I wanted to know the probability of drawing an ace, I know there are 4 aces in a deck of 52 cards. And so that probability would be 4 out of 52. And I can write that as a fraction. I can write that as a decimal if I wanted to do 4 divided by 52 on my calculator. We typically round decimal probabilities out to 4 decimal places. So I would record this as 0.0769. Or we can write it as a percent, where I take that decimal and I multiply it by 100. So I could also report this as the probability of drawing an ace is 7.69%. Let's go ahead and do another example. Here it says, suppose we roll a fair 6-sided die. What is the probability that we roll a 6? What is the probability we roll an even number? So we'll start with rolling a 6. If I want to know the probability of rolling a 6, I need to know how many 6s are on a standard 6-sided die. And I know that a standard 6-sided die has the numbers 1 through 6 on its sides. So my possible outcomes when I roll my dice are the numbers 1 through 6. I see 1 6 in that set, so there's only one way I can roll a 6. And I see 6 total possible outcomes. So the probability of rolling a 6 is 1/6, or 0.1667, or 16.67%. If we do the same for even numbers, for my fraction on the top in the numerator, I need to count the number of even numbers. And 2 is even, 4 is even, 6 is even. So there's 3 ways to get an even number out of 6 possible outcomes. And 3 over 6 reduces to 1 over 2, which I know is 0.5 or 50%. Half the numbers in that list are even numbers. Empirical probability is very similar. For empirical probability, we're going to take the class frequencies and then we're going to divide it by the total frequency. So we have an example here. It says below is a frequency table for the distribution of AP Statistics exam scores for 2025. Based on this data, how likely is it a student is to earn a score of 3? How likely is it a student is going to earn a 4 or higher? Ugh, reading is hard today. So we'll start with earning a 3, P3. First, I need to know how many students got a 3. And I can see in my table that that's this row here. So in this population of students, 8 students got a 3. I then need to know the total number of students. So we're going to have to add down this table to get our total. So 25 plus 15 plus 8 plus 5 plus 2, assuming I added that correctly, is, oh, no, Mr. J, that's a typo. There we go, 55 students. So the bottom of this fraction is 55. And if I wanted it in decimal form, I do the division, and I get 0.1455 rounded, or 14.55%. For P3 or higher, it's a similar idea. I want to look for the frequencies for the classes that fall in this grouping, and then divide them by the total. And looking in the table, 3 or higher would be a 3, a 4, or a 5. So the number on top should be the sum of these frequencies. And 8 plus 2 is 10, plus 5 is 15. So there are 15 students in this group that got a 3 or higher, and we know there are 55 students in the group. I can reduce that. Both of them are divisible by 5, so that would be 3 over 11. I could also do this on my calculator. 15 divided by 55, and I get 0.2727, or 27.27%. If you want a reduced fraction, now that I have my fraction in decimal form, if I go to Math, and I select that first option, to fraction, and press enter again, it'll turn my answer into that reduced fraction. So if you're ever asked to reduce a fraction, your calculator can do that for you if that's a struggle point for you in math class. Okay, some quick notes, and then we'll be done. So first, probability should always be, in decimal form, a number between 0 and 1. If you're in percent form, it'll be between 0 and 100. Meaning I should never have a negative number, should never have a number bigger than 1 or 100%. A 0 means the event will never happen. It's not possible. On planet Earth, I am fairly certain that the probability of seeing a flying pig is 0, right? Pigs don't have wings. That should never happen. A probability of 1 means the event will happen every time. For example, if I am playing a game with a standard deck of cards, I am always going to draw a red or black card because every card in the deck is red or black, meaning the probability of drawing a red or black card is 1. It will happen every time I pull a card from the deck. The last thing is if I sum up the probabilities for all of the possible outcomes for a probability experiment, like rolling a die, 6-sided die, those probabilities should add to 1, or 100%, because I have accounted for all my possible outcomes. That's everything that could possibly happen. That's not going to trip you up this week, but later this semester, or this course, we're going to start calculating probability as it relates to making statistical inference. It is important that you remember this rule because that applies to every probability we calculate regardless of context. So when you're giving me your answers, make sure that it's not negative and make sure that it's not bigger than 1. There are a couple of words that came up while we were doing this video, and I'd like to make sure that we know what they are. So an outcome is a single possible result of a statistical experiment. So when I roll the die, rolling a 1 is a single possible result. That's an outcome. If I scroll back up to our die example, that is a list of all my possible outcomes. That's an outcome, that's an outcome, that's an outcome. Each individual number in that list is a possible outcome. An event is a set of possible results or a set of outcomes. If I scroll back to that die example, the second probability we calculated was P even. Even is an event. That was 3 separate numbers. That is a set of results or a set of outcomes. Typically, when the thing we're calculating the probability for is a single outcome, that's a simple event. When it's multiple outcomes, it's a complex event. You don't have to remember that vocabulary. You do need to remember that an event can include multiple possible outcomes. Our last new word that we're going to see throughout this chapter is sample space. And the sample space is the list of all possible outcomes. For our die example, when we started calculating probability, that was the very first thing that I built. And in general, that's true. I want to know what my sample space looks like before I start trying to calculate that probability. For empirical probability, my sample space is usually given to me as part of that frequency table. All right, if you have any questions on anything in week 2, feel free to send me an email or drop by our office hours on Thursday. Otherwise, I'll see you in the next video.